So if the variable is 1 like x or y, then they are called as linear inequalities of one variable. Set of whole numbers is denoted as 0 as well as all natural numbers. So these are the whole numbers. X belongs to minus infinity comma 2 is the solution set for this given linear inequality. The inequality does not change in the same number is added to both sides of the inequality. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the temple of excellence. Today in this session I am going to take very easiest and important chapter, that is linear inequalities. This is very important chapter and very easiest chapter. Let us know regarding the weightage for this chapter. So here in this chapter you are going to get 6 marks for this chapter. So you will have one 4-mark question and one 2-mark question. So usually the 4-mark question is solving the linear inequalities of two variables by graphical method. And here simple problem finding the solution of a given linear inequality. Now, so here one 2-mark question and one 4-mark question, totally 6 marks question you are going to get. So this linear inequality is very important, and we are using the concept of this linear inequalities, that is finding the solution of given equation, linear inequalities, graphical method. This type of problems we are used to solve in linear programming problems. So this is very important and very useful to solve the problems in linear programming problems. So those linear programming problems techniques is also can be used in almost all fields of science and engineering, particularly in the field of economics as well as in industries. Now in this chapter we are going to study solving the linear inequalities of one variable, two variables, and solving the linear inequality of two variables by graphical method. That's it, very simple chapter. Now let us come to the definition. What is the definition? Let us know the synopsis. So here two algebraic expressions related by the symbol less than, greater than, less than or equal to, or greater than or equal to forms an inequalities. The symbols like less than, greater than, less than or equal to, greater than or equal to will form an inequality. So a symbol like less than, greater than, less than or equal to, greater than or equal to will form an inequality. Now inequality in the form, any equation in the form ax plus by is less than 0, or ax plus by less than or equal to 0, or ax plus by is greater than 0, or ax plus by is greater than or equal to 0 are all inequalities in two variables, that is x and y. There are two variables. How many variables are there? Two variables, that is x and y. So these are called as linear inequalities in two variables. So an equation involving two variables x and y, and the inequalities like less than, greater than, less than or equal to, greater than or equal to will form a linear inequality in two variables. So inequalities in the form ax plus by less than 0, ax plus by less than or equal to 0, ax plus by greater than 0, or ax plus by greater than or equal to 0. These are all forms linear inequalities in two variables x and y. Now inequalities in the form ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, or ax plus b is greater than or equal to 0, they are all called linear inequalities in one variable. How many variables are there? There is only one variable, that is x. Therefore these are all called as linear inequalities of one variable. So if the variable is 1 like x or y, then they are called as linear inequalities of one variable. If the variables of two variables like x and y, they are called as linear inequalities of two variables. So these are called linear inequalities of two variables, and they are called as linear inequalities of a single variable, one variable. Now how to solve these linear inequalities of one variable and two variables? Let us discuss regarding the working rule to solve these linear inequalities. So the inequality does not change in the same number is added to both sides of the inequality. So if you add same number on both sides of the inequality, then the inequality does not change. So the inequality will not change whenever the same quantity is added on both sides of the inequality. Now the inequality does not change if you multiply or divide both sides of inequality by the same positive real number. So the inequality does not change if you multiply on both sides the inequality by the same positive real number. Similarly, the inequality reserves its direction if we multiply or divide both the sides of inequality by the same negative real number. So if you multiply or divide by the same negative real number, the inequality reverses its direction. The direction will reverses. Less than or greater than will changes. So the inequality reverses its direction if you multiply and divide both the inequalities by a negative real number on both sides. Okay. Now these are the working rules which we are going to use to solve the problems. Now let us come to the first problem. Before going to the first problem, you might have been studied in previous class that the set of natural numbers is denoted as n. N is the set of natural numbers, that is all counting numbers, they are called as the set of natural numbers. And the set of whole numbers is denoted as 0 as well as all natural numbers. So these are the whole numbers. Whereas the set of integers is denoted as I or Z. I or Z is a set of integers which contains 0, plus or minus 1, plus or minus 2, etc. These are the set of integers. And the set of rational numbers is denoted as P by Q. So that is denoted as Q. Q is equal to P by Q such that P and Q belongs to any integer and Q is not equal to 0 is the set of rational numbers. That is set of natural numbers, set of whole numbers, set of integers and set of natural numbers. And you know set of real numbers is R. R plus is the set of all positive real numbers. R minus is the set of all negative real numbers. So these are few representation of the sets of numbers. We have studied this in our previous classes. Now based on this, let us come to the problems. Okay. Now let us come to this problem first. Now solve the following inequality in one variable. Let us discuss one variable first. Now very simple, this 3x minus 4 is greater than 7 minus 2x where x belongs to any real number. X belongs to any real number. Just transfer this, that's all. So what is the given equation? 3x minus 4 is greater than 7 minus 2x. 7 minus 2x. So this can also be written as 3, transfer this becomes 3 plus 2x is greater than 7 and minus 4 becomes plus 4. So 3x plus 2x is greater than 7 plus 4. So 3 plus 2 is 5x which is greater than 7 plus 4 is 11. So that means x is greater than, divide by 5, 11 by 5. So x is greater than 11 by 5. That's it. Okay. Now therefore the value of x is greater than 11 by 5 means therefore we can write x belongs to 11 by 5 etc. the last number etc. the infinite number. So therefore here x is greater than 11 by 5 belongs to R. Therefore x belongs to the values 11 by 5 etc. up to infinity. So this can be represented on a number line like this. Let us write a line. This is 0, this is minus infinity, this is plus infinite, this is plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Okay. Now what are the values here? X belongs to 11 by 5 comma infinity. Actually 11 by 5 is nothing but 5 2s are 10 and almost it is equal to 2.2. So that means here it is the number. So therefore this number and greater than this plus infinity. So these values are the values of the solution. So therefore here x belongs to 11 by 5 infinity means so 2.2, 3, 4 etc. up to infinite term is the representation of this solution on the number line. This is how we are going to represent it on a number line. So in the examination they may ask for 2 marks. Just solve the following inequality and represent the solution in on the number line means this is how we are going to represent, all positive towards the right and negative towards the left hand side of the line, the straight line. Okay. And therefore the solution set is, this is the solution set. That's it. So the solution set is x belongs to 11 by 5 comma infinite. Now let us take a similar type problem. Solve the following inequality in one variable. Okay, what is given? Same type problem. 5x minus 3 is less than 7. So given equation is 5x minus 3 is less than 7, or we can also write 5x is less than 7 plus 3, 5x is less than 10, which implies x is less than 10 by 5, x is less than 2. Therefore, the solution set is, solution set is here 2 and less than 2. Less than 2 means 2, 1, 0, minus 1, minus 2, etc. Here it is 3, etc. So this is the solution set. So therefore, here 2 less than 2 and less than 2 is nothing but minus infinity. This is the solution set. So minus infinity comma 2 is the solution set. So x belongs to minus infinity comma 2 is the solution set for this given linear inequality. Now how to represent this on the number line? Now these are the values plus, plus 1, plus 2, etc. plus infinity, and here it is minus 1, minus 2, etc. This is minus infinity. So 2 and less than 2 means these are the values. So this will comes under the representation of the number line. So these values, that is 2 to minus infinity. This is how we are going to represent it on a number line. That's it. Okay. Now let us come to the next problem. Solve the following linear inequality in one variable. 4x minus 2 is less than 8 where x belongs to R. Okay. Now what is given? 4x minus 2 is less than 8. That is 4x is less than 8 plus 2. 4x is less than 8 plus 2 is 10. X is less than 10 by 4. So that means x is less than 5 by 2. X is less than 5 by 2. Less than 5 by 2 means, therefore, x belongs to the value 5 by 2 and less than 5 by 2 is minus infinity is the solution set. Therefore, x belongs to minus infinity comma 5 by 2 is the solution set. That's it. Okay. Now, let us take next problem. These are all 2 marks questions. Very simple. 5x minus 3 less than 3x plus 1 where x belongs to R. So, this can also be written as the given equation 5x minus 3 is less than 3x plus 1, 5x minus 3x is less than 1 plus 3. Transfer this. Minus 3 becomes plus 3 and plus 3x becomes minus 5x. 5 minus 3 is 2x is less than 4. X is less than 4 by 2, which means x is less than 2. That's it. Okay. So what is the solution set? That is belongs to R. Therefore, x belongs to less than 2. 2 and less than 2 means 1, 0, minus 1, minus 2. So that is nothing but minus infinity. This is how we are going to write the solution set for. Suppose if we want to represent this on the number line, let us write the line. This is the line plus infinity and minus infinite. This is 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Here it is 2 and less than 2. So this is 2 and less than 2 up to infinity. So these are the values. So that is x belongs to minus infinity comma 2. This is how we are going to represent it on a number line. That's it. Okay. So if you do this much, you will get 2 marks. Now let us come to the next problem. Solve the following linear inequality in one variable. Same type problem. What is given here? 3 into x minus 1 less than or equal to 2 times x plus 3. Now this can be written as 3 into x minus 1 less than or equal to 2 times x plus 3. Now multiply it. 3x minus 3, which is less than or equal to 2x plus 3 2s are 6. That's it. Now this can also be written as usual 3x minus 2x is less than or equal to 6, minus 3 becomes plus 3. 3x minus 2x is x, which is less than or equal to 9. X is less than or equal to 9. Okay. Now therefore, what is the solution set? So therefore, x belongs to, what is this? 9, and less than or equal to 9 is nothing but minus infinity. So that is x belongs to minus infinity comma 9. So therefore, the solution set is x belongs to minus infinity comma 9. This is the solution set. That's it. Okay. Of closed and of open interval, because less than or equal to. So all the values which lies between minus infinity to less than or equal to 9 means including 9 and less than 9. Including 9 and less than 9 is denoted as big bracket, that is of closed and open interval, x belongs to minus infinity comma 9. That's it. Okay. Now let us take a next problem. Solve the following linear inequality in one variable. 3x plus 8 is greater than 2 where x belongs to I as well as x belongs to real numbers. So what is given? 3x plus 8 is greater than 2. Therefore 3x is greater than 2 minus 8. 3x is greater than minus 6. X is greater than minus 6 by 3, which is x is greater than minus 2. So x is greater than minus 2. Okay. Now, therefore, x is equal to minus 2. X is greater than minus 2. Now, there are two cases. Case 1, when x is an integer. That is, x belongs to I. If x belongs to I, what is the solution set? So, when x is an integer, the solution set is, therefore, this is minus 2, minus 1, 0, 1, 2, 3, etc. minus 3, minus 4, etc. This is the solution set. X belongs to 0, 1, 2, 3 and minus 1, minus 2, minus 3, etc. where x is greater than minus 2. Okay. Now, therefore, in this solution set, what is the condition? X is greater than minus 2. X is greater than minus 2 means, therefore, the set of values are, that is nothing but 0, 1, 2, 3, 4, etc. and minus 1. That's it. So, these are the values which comes under this set where x belongs to any integer. Okay. So, x belongs to these values minus 1, 0, 1, 2, 3 when x belongs to any integer. Now, so when x belongs to any integer, therefore the values are minus 1, 0, 1, 2 and 3, etc. Okay. And the second case, x belongs to the real number. Okay. So, here what is the value? X is less than 2. So, therefore, when x belongs to real numbers, we can write the values from minus 2 to plus infinity. X is less than minus 2, etc. up to plus infinity. That's it. Okay. This is how we are going to solve this problem where x belongs to. So, here x belongs to I and x belongs to I. X belongs to real numbers means all the values which are greater than minus 2 is minus 2 comma infinite. And all the values which belongs to I integers means which are greater than minus 2 is minus 1, 0, 1, 2, 3, etc. That's it. Now, let us come to the next problem. X by 3 greater than x by 2 plus 1 where x belongs to real numbers. Okay. Now, this can be solved very easily. Just here x by 3 is greater than x by 2 plus 1. This can also be written as x by 3 minus x by 2 is greater than 1. Take LCM. 6 is the LCM. This is 2x minus 3x is greater than 1. So, 2x minus 3x is minus x by 6 is greater than 1. Minus x is greater than 6. So, therefore, x is less than minus 6. That's it. Okay. X is less than minus 6 means, therefore, the value of x belongs to all the values minus 6 and less than minus 6. Okay. Minus 6 and less than minus 6 is denoted as minus 6 comma minus infinity. So, that is nothing but minus 6 and less than minus 6 is minus 7, etc. up to minus infinity. So, therefore, the solution set is x belongs to minus infinity comma minus 6. That's it. Okay. Now, let us come to the next problem. Similar type problem. 7x plus 3 less than 5x plus 9. So, this can be written as 7x plus 3 less than 5x plus 9 or 7x minus 5x is less than 9 minus 3. 7 minus 5 is 2x which is less than 9 minus 3 is 6. X is less than 6 by 2, that is x is less than 3. Okay. So, x is less than 3 means, therefore, solution set x belongs to x less than 3. 3 and less than 3 is minus infinity. That's it. Minus infinity comma 3. That's it. Okay. Now, let us come to the next problem. Now, this is 3x minus 4 divided by 2 which is greater than or equal to x plus 1 by 4 minus 1 where x belongs to real number. Now, just take LCM and simplify. That's it. 3x minus 4 by 2 which is greater than or equal to, take LCM, 4 is the LCM, x plus 1 minus 4 ones are 4. This is 3x minus 4 by 2 which is greater than or equal to x 1 minus 4 is minus 3 divided by 4. Just cross multiply it. That's it. 4 3s are 12x minus 16 which is greater than or equal to 2x minus 6 or 12x minus 2x is greater than or equal to minus 6 plus 16. That is equal to 12x minus 2x is 10x. 10x which is greater than or equal to 16 minus 6 is 10. So x is greater than or equal to 10 by 10, that's equal to 1. So x is greater than or equal to 1. So x is greater than or equal to 1. Therefore, we can write x belongs to 1 comma infinity. That's it. Very simple here. So 3x minus 4 by 2 which is greater than or equal to, take LCM, 4 is LCM, x plus 1 minus 4, 1 minus 4 is minus 3 by 4, cross multiplied, 4 is a 12x, 4 4 is a 16x which is greater than or equal to 2x minus 6. So just transfer this, very simple, 12x minus 2x is 10x which is greater than or equal to minus 6 plus 16 is 10. So 10x is greater than or equal to 10 means x is greater than or equal to 10, that is which is greater than or equal to 1. So x is greater than or equal to 1 means the solution set is x belongs to 1 comma infinite. That's it. Okay. Now how to represent this set on the number line? So this can be represented, this is plus infinity, 0, minus infinity, and how to represent this on the number line? So plus infinity, so x is greater than or equal, this is 1. So this is greater than or equal to 1, we are going to represent here. That's it. That is a representation. Okay. Now, let us come to the next problem. Now, solve the following and represent it on the number line. 5x minus 3 is less than 3x plus 1. Here, given equation is 5x minus 3 is less than 3x plus 1. 5x minus 3x is less than 1 plus 3. 5x minus 3x is 2x is less than 4. X is less than 4 by 2, which is x is less than 2. So, therefore, the solution set is x belongs to less than 2. Less than 2 means this is 2 and less than 2 is minus infinity. Minus infinity comma 2 is the solution set. That's it. Now how to represent it on the number line? See, this is 0, plus 1, plus 2, minus 1, minus 2, plus infinity and minus infinity. X is less than 2. Here it is 2. This is 3. This is 2 and less than 2 is this side. This is 2 and less than 2 comes here. So this is the solution set on the line graph. That's it. Okay, less than 2. So this is how we are going to represent it on a number line. So here the solution set is x belongs to minus infinity comma 2, and the number line, this is plus 2 and less than plus 2 is up to minus infinity. That's it. Okay. So these are few type of problems in linear inequalities in when one variable. Hope you followed all these type of problems. Very simple for 2 marks. So these are all simple problems for 2 marks. That's all regarding today's session. Let us meet with the different type of problems in the next session. Thank you. Thank you very much.